Right, so those first two, you adjust the flow down and get an equivalent flow. So that's how the first two of them work. So you don't adjust the head loss with the new C value, you adjust the flow, and that indirectly adjusts the head loss. So that the flow you'd use for the tables on the first one is 400 gallons per minute, and for the second one it's 500 gallons per minute. Okay. And then you just find the head loss for those equivalent flows, they're called. Okay, the next one there, the radius is 4.5 inches. You want to convert that into feet. It's 0.375 feet. Pi r squared for a circle gets you 0.442 square feet. Multiply that by the velocity, you get the flow rate, 1.10. Okay. So that one goes. All right, the next one there, you want to find the pressure head for 50 psi. It's 115.5 feet. Find the head loss, 400 gallons per minute, 700 feet of 6-inch pipe C100, 2.2 times 7, because there's 700 feet, it's 15.4. So you got 450 feet elevation, you've got 115.5 feet of pressure head, and add them up, you get the total amount of energy. Subtract off the head loss, you get 550.1. 293 feet of elevation there. Take away the, start with the total, take away the elevation, you get 257.1. That's how much energy you've got left over for pressure. Convert that into pressure in PSI, you get 111 PSI. Okay. Is that all right on that one?
I'm okay.
Wait, we good?
He's with us.
Oh, I'm sorry.
Here. Yeah.
Okay, the next one, you've got 4-inch pipe is 0.333 feet of diameter. Get the L over D values for the two fittings, the open check valve and the elbow. Convert those into feet. When you add them up, it's 50.67 extra feet of pipe caused by those fittings. Add that to the other lengths of pipe, you get 190.67 total. So you got, what, 80 and 60 gets you 140, and then you've got these two fittings that you want to find equivalent lengths for. So you multiply both of those L over D values by the pipe diameter, which is 0.333 feet. 4 inches is 0.333 feet. Add them up, so that gets you an extra 50.67 feet of pipe. Add all that up together, you get 190.67. Multiply it by the head loss, which is pretty high for that. It's 33.45 feet per 100. You get 63.78 feet of head loss for that one. All right. So that's how that works. All right, the last one there, what you want to do is figure out the energies for both sides. So at the reservoir, it's just 450 feet of elevation. The hydrant has 240 feet of elevation, plus the required pressure is 20 psi. That's 46.2 feet. Add those up, you get 286.2. All right, so what you want to do is find the difference between those two values, and it's 163.8. So you can lose 163.8 feet of energy for that water running down that 2,100 feet of pipe and still maintain the 20 psi residual. That's the idea on that one. All right, now you got 2,100 feet of pipe, so if you take the total amount of loss you can have, which was 163.8, divide it by 21, you get 7.8 feet per 100 feet. That's what you can have, okay? So you want to go look at on the charts for that. All right, so for 8-inch pipe, that's just about 1,700 gallons per minute. It's just a little bit less. I called mine 1,690, whatever. I mean, you know, somewhere around 1,700, a little less. All right, but that is coming off the chart, so that's an equivalent flow. Okay, so the equivalent is the actual times C 100 over C, so the actual is the equivalent times C over 100. So you're going to get more flow through this. Okay, so if you take the 1690 and factor it up by 1.2, you get somewhere around 2,000 gallons per minute. Okay. So that's how that one works. Okay. We doing all right with that? Why not just? I'm just. What I'm going to do? I'll